Okay, so for this intro video, we're going to be doing the two parent graphs of our trig functions, cosine and sine. So for this first one, I'm going to be doing the parent function of cosine. So we can do f of x equals, or you could do y equals the cosine of x. And we look at what we're doing for cosine, it's always the x coordinate of my point. So we're not even worrying about the y coordinate at all for this parent function of our unit circle. And when I look at the radians that my x-axis is dealing with, I'm going from 0 to pi over 2 to pi to 3 pi over 2 to 2 pi. So I'm going to circle those in my unit circle so that I can see the information more clearly. So we're starting at 0 radians, and then we're jumping right to pi over 2 radians, and then we're jumping to pi radians, and then 3 pi over 2 radians, and then we're back to where we started, a full rotation of 2 pi. And remember, we're talking about the x coordinate of all of these. So if I'm finding the cosine of 0, I'm worried about the x coordinate right here, which is 1. So at 0 radians, I'm going to go up 1. For my next jump, I'm looking at pi over 2. So finding that on my unit circle, cosine of pi over 2, my x coordinate is 0. So pi over 2 gets a dot at 0. For my next coordinate, cosine of pi takes me down to -1. So looking at pi, I go all the way down -1. I need cosine of 3 pi over 2, which is 0. And then one full rotation taking me back to 2 pi ends up being at 1. So we can draw the curve that connects these dots. And we can continue on going to the right forever or going to the left forever. I'm going to do one full rotation. We were just working in the positive direction of going counterclockwise. I'm now going to work in the negative direction of going clockwise. So we already have the 0, 1 right there. If I go clockwise by pi over 2 radians, I end up at 0. And then another to negative pi, I end up at -1. Going further, -3 pi over 2 ends up back at 0. And then finally, going a full rotation of negative takes me back to 1. So we can connect our curve. And we're going to place arrows on them, showing that they do continue on forever. For our second graph, I'm going to be doing the sine parent function, which is now dealing with the y coordinate. So I'm doing the parent function for f of x, or y equals the sine of x. I'm dealing with the same radians that I was dealing with before. So we're jumping from 0 to pi over 2 to pi to 3 pi over 2, and then back to 2 pi. Now we're just looking at the y value of the coordinate each time. So starting at sine of 0, my y coordinate is 0. So 0 starts at 0. Going to sine of pi over 2, my y coordinate is 1. So pi over 2 gets 1. Sine of pi is back to 0. Sine of 3 pi over 2 is -1. And then sine of 2 pi back to my full rotation of 0. And we can connect these ones with our curved line. And we're going to continue it on into the negative direction again. So I already have my 0, and then I need to go down to -1, and then back to 0, and then to +1, and then to 0.